So now we're going to learn how to find the least common denominator, also known as the lowest common denominator, or LCD, for two fractions using prime factorization. And if you don't know what prime factorization is, you can check out my earlier video, which you can see now in the top right hand of your screen. So if we're going to try to find the least or lowest common denominator between two fractions, essentially what we are doing is we are trying to find the least common multiple amongst the two denominators. So the least common multiple for 60, which is the denominator of 6, or rather 7 over 60, and 18, which is the denominator of 11 over 18. So let's go ahead and find the least common multiple for 60 and 18 using prime factorization. So just as we have started with the prime factorization videos, let's go ahead and write ourselves a list on the left hand side of the 10 smallest prime numbers. So the 10 smallest prime numbers, the first 10 prime numbers, are simply 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. And if you cannot remember these, or you cannot find these online, I have another video for you that shows you how to calculate, or rather find, prime numbers, and you can see that video right now in the top right hand of your screen. So let's go ahead and prime factorize these two numbers. So let's start with 60. So 60 is an even number, therefore it is definitely divisible by 2. So let's go ahead and divide it by 2. We're going to have a 2 over here, and then 60 divided by 2 is just equal to 30. Now let's go and prime factorize 30. Well, 30 is clearly divisible by 2, so let's go ahead and do that. So we're going to have 2, and then 30 divided by 2 is just equal to 15. And now 15, well, 15 is not an even number, so it won't be divisible by 2, but 15 is divisible by 3. So let's go ahead and divide 15 by 3. So we're going to get 3 and 5. So do we have the prime factorization of 60 now? Well, 2 is a prime number, 2 is a prime number, 3 is a prime number, and 5 is a prime number. Therefore, we have a prime factorization of 60. So we have 60 is equal to 2 times 2 times 3 times 5, or alternatively, 60 is just equal to, we can combine these two 2's, 2 times 2 is simply equal to 2 squared times 3 times 5. This is equal to 60. Okay, and now let's do the same for 18. So 18 is clearly an even number, so it is divisible by 2. So we're going to get a 2. And then 18 divided by 2 is just equal to 9. Now, is 9 a prime number? When we check our list, 9 is not on the list, so 9 is not a prime number. 9 is not an even number, so it's not divisible by 2. Is 9 divisible by 3? Yes, it is. 9 divided by 3 is just equal to 3. So we can prime factorize 9, and we can get a 3 and a 3. Is this a prime factorization of 18? Well, let's have a look. 18, or rather 2, is a prime number. 3 is a prime number. And 3, again, is a prime number. So this is a prime factorization of 18. So we have 18 is equal to 2 times 3 times 3. Or alternatively, 18 is equal to 2 times, we can combine these two 3's, we're going to get a 3 squared. And this is equal to 18. Right, so how are we going to find the least common multiple using this guy and this guy? These two prime factorizations. Well, in order to find the least common multiple, you're going to have to take the prime with the highest power across each of these two for every prime that you see on the right-hand side of each of these two equations. So, for instance, do we see a 2? Do we see the prime 2 on the right-hand side of this equation? Yes, we do. We see 2. It's 2 squared. So it is 2 to the power of 2. Do we see a 2 on the right-hand side of this equation? Yes, we do. We see a 2, but it's only to the power of 1. But we're going to take the highest power. So here we have a 2 to the power of 2. Here we have a 2. 2 here is implicitly to the power 1. So this is a 2 to the power 1. 2 to the power of 2 is a higher power than 2 to the power of 1. So when we're trying to find our least common multiple, when we are trying to find our least common multiple or lowest common multiple, this is going to be equal to, well, like I said before, here we have a 2 to the power of 2, here we have a 2 to the power of 1. You're going to take the one that has the higher power, so 2 to the power of 2. And then you're going to multiply, the remaining primes with the highest power. So is there a 3 on the right-hand side of this equation? Yes, there is. It's implicitly to the power 1. Is there a 3 on the right-hand side of this equation? Yes, there is. It's to the power 2. So 3 to the power of 2 is raised to a higher power than 3 to the power 1. So you're going to take the 3 to the power of 2. So here in your least common multiple equation, you're going to take 3 to the power of 2 from this equation over here. Now, is there a 5 on the right-hand side of this equation? Yes, there is. Is there a 5 on the right-hand side of this equation? No, there isn't. Well, I mean, implicitly, there is a 5 on the right-hand side of this equation. It's just a 5 to the power of 0, because 5 to the power of 0 is equal to 1. And if you multiply anything by 1, you get itself. So there is a 5 to the power of 0. Here you just have a 5. So implicitly this 5 is to the power of 1. So you're going to want to take this 5 to the power of 1 because 1 is greater than 5 to the power of 0, which is implicitly over here. So you are going to multiply this by 5 to the power of 1, or simply just 5. So this is your lowest common multiple. Now let's see what this number actually is. So 2 squared is just equal to 2 times 2, which is equal to 4, times 3 squared is equal to 3 times 3, which is just equal to 9, times, this is just equal to 5. Whoops. 5. Right. And now, you just perform the multiplication. So let's multiply the first two numbers first. It doesn't matter which order you perform the multiplication in. 4 times 9 is equal to 36. Times this 5. And so your least common multiple is equal to 36 times 5. 36 times 5. So 36 times 5 is equal to 180. So your lowest common multiple is equal to 180. Now, how does this help us? Well, this lowest common multiple of 180 is actually going to be your lowest common denominator in the problem that we are trying to solve. So remember where we started. We started off with these two fractions, 7 over 60 and 11 over 18. 7 over 60 and 11 over 18. So let me write that over here. We have 7 over 60 and 11 over 18. And I am claiming that the lowest common denominator for these two fractions is going to be 180 because it is the lowest common multiple of 60 and 18. And now the question is, how are you going to convert these fractions to equivalent fractions that have a denominator of 180? A denominator of 180. Well, there is a very easy way to do that using prime factorizations. So if you recall, 60 is equal to 2 squared times 3 times 5. So this fraction over here is equal to 7 over 2 squared times 3 times 5. And then, if you recall, this fraction over here is, or rather 18, is just equal to 2 times 3 squared. So this fraction over here is equal to 11 over 2 times 3 squared. Okay? And if you remember, our lowest common multiple here is equal to, over here we have it 2 squared times 3 times 5, or rather 3 squared times 5. 2 squared times 3 squared times 5. So if you just focus on these three lines, it will be immediately obvious, or almost immediately obvious to you, how you can convert these into equivalent fractions. Well, notice that 60 is 2 squared times 3 times 5, but the lowest common denominator is 2 squared times 3 squared times 5. So what are we missing in this denominator? We're missing a 3. So what you have to do is you just have to multiply the numerator and the denominator by 3 over 3. Because this denominator here, 60, as it is prime factorized, is just missing a 3. It's just missing a 3. Does it have a 2 squared? Yes, it does. It has a 2 squared. Does it have a 5? Yes, it does. Does it have a 3 squared? No, it just has a 3. But 3 times 3 is 3 squared. So if you multiply by 3 over 3, which is equal to 1, any number over itself is equal to 1, then in the denominator, you are guaranteed to have 180. And in fact, if you multiply just 60 by 3, you will also realize that that is equal to 180. What about this guy over here? What about 11 over 18? Well, you've got 2 times 3 squared. So does it have a 2 squared from our lowest common multiple? No, it doesn't. It just has a 2. So you're going to have to multiply the numerator and the denominator by a 2. Because a 2 times a 2 gives you a 3 squared. Does it have a 3 squared? Yes, it does. Does it have a 5? No, it doesn't. So you're going to have to multiply times a 5. And obviously the same for the numerator, 2 times 5. Because when you multiply any number by 1, and this is 2 times 5 over 2 times 5, so this whole bracket here has a 1, then that number is the same. So let's perform this calculation. So let's start with the left-hand fraction first. This is just equal to 7 over 60. That's over here. I'm just copying this. So this guy over here is equal to 7 over 60. And then we are just going to multiply this by 3 over 3. And let's perform the step on this line. So we have 11 over 18. And this is multiplied by, well, 2 times 5 is just equal to 10 over 10. 2 times 5 is 10. Okay, and now we just have to perform very simple algebraic steps to get equivalent fractions. So on the left-hand side here, 7 times 3 is equal to 21. So we're going to get 21 in the numerator. And in the denominator, 60 times 3, well, it has to be equal to our lowest common multiple unless we made a mistake somewhere. So 60 times 3, 3 times 6 is 18, plus add a 0, 180. Right? Our lowest common multiple, which in this case is going to be our lowest common denominator. And this is, of course, equal to 7 over 60. From over here, 7 over 60. And what about on the left-hand side over, or rather on the right-hand side over here? On the right-hand side over here, you're going to have 11 over 18 is equal to 11 times 10. Well, any number times 10, you just tack on a 0 at the end. So it's 110. 110. And then 18 times 10 is equal to 180. So there you have it. The lowest common denominator for 7 over 60 and 11 over 18 is 180. 180. And I've also shown you how to very easily convert these fractions into equivalent fractions with that lowest common denominator using prime factorizations. So these are your final answers.